Good evening, everybody from different parts of the world. I really appreciate all of you joining and your patience. And this is Krishna Badula from India, Hyderabad, India, representing IUCEE, the Universal Collaboration for Engineering Education. So this is a webinar in collaboration with IUCEE along with IFEES. And we have Hans Carr from IFEES, International Federation of Engineering Education Societies, and GEDC, Global Engineering Games Council. So welcome to everybody from different parts of the world. Good morning, good afternoon, good evening. Today we have an outstanding speaker, and I will just take a few minutes to talk about him. Dr. Christopher Carr serves as the Associate Dean for Outreach, Student Success, and Engagement. It's an extremely important area, which is Deputy Title 9 Coordinator within the College of Engineering and Computing at George Mason University. From 2022 to 2025, this was on loan from George Mason to the Environmental Protection Agency, EPE, where he served as the inaugural senior advisor to the Administrator for Organizational Development and Culture. Chris has worked at the intersection of creating accessible and engaging STEM environments across nonprofit, higher education industry, and government organizations. So with that brief introduction, we just listen to you. Chris, go ahead.
Wonderful. Thanks so much, Krishna. Hello, and thank you all. A special thanks to IFEES, GEDC, as again, IUCEE for this opportunity to present. It's 9 a.m. here in it was like the Washington, D.C. area. But I'm going to do my absolute best to make sure that this is interesting and engaging for those of you who are just kind of getting home from work or maybe even getting ready for bed. My topic is, engineering beyond borders, empowering the next generation of global engineering and computing leaders. Well, why is this topic so important to me? Well, first, it's because to sum it up, I believe that engineering education is experiencing a crisis of relevance. Why? Well, because increasingly we're seeing that technical skills alone are insufficient for global leadership. Let's look at this from some of the perspectives of some texts that really kind of influence, I think, higher education and the ways in which we approach engineering education. This is Malcolm Gladwell. He wrote a book, Outliers, and he has something what I like to call the 10,000-hour myth. So Malcolm Gladwell popularized the 10,000-hour rule, which suggested that mastery in a field required roughly 10,000 hours of deliberate practice. Here's how I think engineering education interpreted that. It said depth over breadth, and that became like the gospel. Specialization equaled excellence, technical mastery equaled career success, more calculus, more physics, more programming, and that led to better engineers. The result, in my opinion, is that engineering curricula really doubled down on the technical depth, and so you had 4 years of increasingly specialized coursework, a focus on individual problem solving, an optimization, focus on technical proficiency, and then the assumption that if you master the technical skills, then everything else would follow. Here's what I hear as an unspoken promise in that. If you put in the 10,000 hours in mastering something like thermodynamics, material science, or algorithms, then you're going to be ready to lead. But here's what industry noted. Industry noted is like in a LinkedIn workforce report in 2019 that communication skills are the #1 shortage, not technical knowledge. In a report by the World Economic Forum, they said that by 2025, and in case you don't know, we're in 2025, is that analytical thinking and creativity would matter more than technical knowledge alone. The Wall Street Journal said in 2017 that employers find soft skills like critical thinking in short supply and that engineering graduates particularly struggle. Major engineering employers end up reporting that graduates can solve equations, but they can't communicate solutions to stakeholders. Technical proficiency is high, but collaboration skills are absent. Individual problem solving is strong, but team leadership is weak. And that engineers struggle with ambiguity, competing interests, and ethical dilemmas. Google's own research and something that they call Project Oxygen, they noted what the top qualities of a successful Google employee were. Number one, being a good coach. Two, communicating and listening well. Three, possessing insights into others. Four, having empathy towards colleagues. Five, being a good critical thinker. Six, being able to make connections across complex ideas. And dead last, STEM expertise. The disconnect is that we're producing technically excellent engineers who can't navigate the human, social, political, and ethical complexities of actual engineering practice. There's been a counter argument that's been coming up recently, and it's gaining momentum. So there's been scholarly pushback by works by David Epstein, who wrote the book Range, Why Generalists Triumph in a Specialized World. He studied Nobel Prize winners and world-class performers and successful innovators. And what he found is that people who opted to specialize later and had a broad expertise or a broad experience were consistently outperforming early specialists. The key insight, I think, from this is that he says, and quote, the most impactful creators have a breadth of training that allows them to draw analogies and make connections across domains. So engineers with liberal arts backgrounds, diverse experiences, and cross-disciplinary knowledge solve complex problems better than those with narrow specialties. Helen Lewis wrote a book that's ongoing called The Genius Myth, and in it she critiques Silicon Valley's worship of what she calls the lone genius, the Steve Jobs, the Mark Zuckerbergs, the Elon Musk. And she argues that the myth is that not only empirically wrong, but it's socially harmful. She notes that the major innovations come from diverse teams that are collaborating, not isolated geniuses. The quote unquote genius engineer narrative often excludes women, people of color, collaborative thinkers, etc. So, what is society demanding of us? Well, I think we can look at some of the most recent engineering crises. I just picked a couple recent ones. So, the Boeing 737 MAX crashes of 2018 and 2019. What they found is that engineers who couldn't or wouldn't communicate safety concerns ultimately led to 346 deaths. In the Flint Water Crisis that lasted from 2014 to 2019, engineers who lacked the social awareness about environmental racism ended up impacting what ended up being a poisoned community. And things like AI algorithmic bias, which is ongoing as we're continuing to still understand and engage with AI, is that engineers who don't understand systemic inequality create technology that amplifies discrimination. The pattern here is that society's most urgent problems require engineers who are able to navigate cultural difference in power dynamics, communicate across discipline with non-experts, understand historical and social contexts, balance competing interests ethically, and work collaboratively across difference. My conclusion from this is that technical expertise is necessary, but it's insufficient. The world needs engineers with range who understand that engineering decisions are always social, political, and ethical decisions. Okay. So this is where I maybe get a little more on the risque side. In 1492, indigenous people found Columbus lost at sea. Well, you may have heard that story a little differently. Well, for centuries, we've been told narratives about discovery, about expertise, about who gets to define excellence. Stories that centered one perspective while relegating others to footnotes or erasing them entirely. We've organized entire educational systems around these narratives. We've built curricula that assume certain voices hold all the answers. We've created hierarchies that determine whose knowledge counts as rigorous and whose gets dismissed as anecdotal. But here's what happens when we cling to those outdated narratives. We keep producing engineers who are brilliant at solving problems that we've told them matter, while missing the problems that actually threaten communities. We keep training leaders who optimize systems, but can't recognize that those systems are fundamentally unjust. The question isn't whether we need to rethink engineering education. It's really, are we brave enough to learn from the voices that we've been taught to ignore? Because here's the uncomfortable truth. The communities that we've pushed to the margins, HBCUs, historically Black colleges and universities, minority serving institutions, indigenous nations, the global South, they've been doing justice-centered and community-engaged and socially aware engineering all along. And it's not because it was trendy, it's because their survival demanded it. So as we move forward today, I'm not asking you to just include often overlooked voices in engineering education. I'm asking, what if those voices have been right all along and we're the ones that need to catch up? Okay. So why do I think that the world needs global leadership now? I think that with the global engineering challenges such as climate change, urbanization, digital equity, they require perspectives that are shaped by justice and equity. The traditional engineering education operates on what I like to call the sequential model. So you learn technical skills in years 1 through 3, maybe add soft skills in year 4, and you hope that leadership emerges post-graduation. But research from MIT's Bernard Gordon's MIT Engineering Leadership Program and Stanford's D School shows that that actually fails because leadership isn't a skill set, it's an integrated practice. Ethical reasoning can't be added later to technical decisions. And cultural competency requires lived practice, not theoretical modules. So we need something like an integration module. As like technical decisions are always social decisions. Every engineering program problem and has stakeholders who define success differently, and leadership develops through recursive practice. So design goes into engagement, goes to reflection, goes to redesign, etc. So when we look at this, is like I like to think through this from strategies. I like to be solutions oriented as much as possible. So one strategy is for us to reframe the curriculum. What if we designed, right now our current way of talking about curriculum is that we say, design a water filtration system that can remove 99.9% of the contaminants. If we looked at this from an integrated approach, we would say, design a water filtration system for Flint, Michigan. Your stakeholders include the residents who distrust government solutions, city officials who are working with limited budgets, community organizers who are demanding transparency, children who need safe water, right? Those are your stakeholders. The question then is, now, how do you balance technical expertise with community trust building? If we look at implementation strategies for this, we might say that we would do this through contextual problem-based learning. So every technical assignment would include something like a stakeholder analysis or community partnership requirements where students interview actual affected communities, or competing interest workshops where the students simulate workshops between engineers, politicians, community members. There's evidence that this works. Olin College's collaboratory research shows there's a 40% higher retention of material, and students report 3 times higher confidence navigating organizational complexity. In strategy 2, I like to call this the developing cultural intelligence model. So going from technical fluency to cultural fluency. This is adapted from Downey and Lucina's global competence model, but engineers need to recognize that problems are defined differently across cultures. What counts as, say, efficiency in Silicon Valley versus efficiency in rural Mississippi, in rural India, and rural Latin America. So if we think about this from concrete practices, we might look at this from ethnographic engineering assignments. So students spend some hours shadowing communities affected by engineering decisions. Maybe they have to identify different ways that community members would define the problem differently than an engineer would. And you could assess this through revised technical solutions based on ethnographic insights. We could also look at it from cross-cultural design studios. Partner with HBCUs or tribal colleges or Hispanic serving institutions or institutions in the global South where you have joint design projects and students are able to navigate different problem definitions. This has been interesting and has worked in places like Howard University, partnered with the Massachusetts Institute of Technology, MIT, and those students co-designed air quality monitors. And what was interesting is that the MIT students were forced to understand the historical distrust of government data collection that happened in communities of color within the United States. Another strategy could also be multilingual technical communication, where you require students to explain their designs to non-technical stakeholders. Because if you can't explain your solution to a community member in their language, literal or metaphorical, your solution isn't finished. So the other strategy is to embed justice frameworks. So I like to call this engineering through an equity lens. So there's something that they call the Justice Questions Protocol that was developed by Dr. Donna Riley. Before finalizing any technical decision, students must address 4 things. Access, so who benefits from this solution and who is excluded. 2, distribution, how are risks and benefits distributed across communities. 3, recognition, so whose knowledge informed this design and whose expertise was dismissed. And finally, 4, participation. Who had decision-making power in the design process? Let's look at this from, say, something like an autonomous vehicle design. So the traditional approach is that we would say we're going to optimize this for speed, efficiency, and cost. A justice-centered approach would say, why do detection algorithms fail on dark skin, right? Access. Which neighborhoods will autonomous vehicles serve first? Distribution. Who decides pedestrian detection is less important than vehicle efficiency? Recognition. And were disability advocates involved in mobility design? Participation. If we looked at this from a pedagogical structure, in years 1 and 2, we might do case studies analyzing past engineering failures through a justice lens. In year 3, we would maybe redesign existing technologies to address justice gaps. And in year 4, we would have capstone projects that required equity impact statements alongside technical specifications. Okay, so in strategy 4, I think this is where we focus on leadership development as a core competency. So to be honest, I really lean into this because my doctorate degree is in interdisciplinary leadership. And so I really kind of think from this lens most often. So in this, we're looking at moving from the individual genius to collaborative leadership. The challenge I think that we have again is that engineering culture tends to worship the lone genius. So the Steve Jobs, the Elon Musks of the world. But the reality is that complex systems require collaborative leadership across diverse stakeholders. If we're looking at this from a model, Bernard Bass and Ronald Riggio have a transformational leadership model that could be adopted for engineering, in which we ask them to have inspirational motivation. So articulate why technical solutions matter beyond metrics. The way we could connect this is that engineering are looking to work for community transformation. And as a practice, students would present designs to community boards, not just professors. We could also use intellectual stimulation. So challenge assumptions about whose problems matter. Question standard approaches that exclude marginalized communities. And as a practice, you could do things like red team analysis, where the teams exercise and students argue against their own designs. There's also individualized consideration. So recognizing that team members bring different forms of expertise, valuing community knowledge alongside of that of technical knowledge, and also peer evaluations that assess how well did you really integrate non-engineering perspectives. Then there's idealized influence or role modeling, in which faculty must demonstrate collaborative justice-centered engineering. Guest speakers could include engineers who left companies over ethical concerns, and you could have case studies of engineers who sacrificed career advancement for ethical principles. As an assessment tool, we could look at portfolio-based evaluations, tracking leadership growth across the 4 years, not just as a final project. All right. And then the final strategy is around institutional accountability. And requires a systems change approach to systemic accountability. So individual strategies are often going to fail without institutional commitment. So we have to think about what the required shifts are. First and foremost, we're in engineering. A lot of us are thinking about this in terms of things like ABET and ABET adjacent criteria. So ABET criteria has to include that we are able to demonstrate cultural competency. Capstone projects is they could, require community partnership documentation. You could do alumni surveys that could track, do graduates understand the social impacts of their work? For faculty development, is like engineering professors need training and facilitation, not just technical content. We should incentivize community engaged scholarship in tenure and promotion. And we should hire faculty who have the lived experience around some of these aspects, whether it's like coming from those communities or working in those communities. And industry partnerships will require restructuring. So corporate partners should demonstrate their commitment to equitable hiring and create internship programs that include placements in community organizations, not just Fortune 500s. And advisory boards should include community advocates, not just corporate executives. And in terms of resource allocation, you have to have funds that go to community partnerships at the same level as research labs, providing stipends for students who do community engaged work. It shouldn't be unpaid and volunteer. And create faculty positions that center justice in engineering education. In terms of accountability metrics, we could look at the percentage of graduates that are working in public interest engineering after, say, 5 years, diversity of the problems students choose to address, not just on profitable tech, and then community partner satisfaction scores. So do communities feel heard ultimately? So I love this picture here. This comes from my days at the EPA. This is EPA Administrator Michael Regan under the Biden administration sitting on a bus that is a electric powered bus that will be going to different communities in the rural south of the United States. And so he's sitting on this bus with all these community partners, showing them how this engineering and this innovation in environmental planning for the community will impact them and their students. So I think again, I use this because I think that for the path forward, we have to have an engineering education that honors complexity. I think it's a false choice to say that it's technical rigor or social awareness. The reality is that technical excellence requires social awareness. What does this look like in practice? So in year one, instead of just having an introduction to engineering course, what if it was an introduction to engineering in society? Students could learn statics and interview community members about infrastructure needs. Lab reports would include both technical specifications and stakeholder analyses. In year two, we would have thermodynamics, but maybe it's taught through an energy justice lens. Who has access to heating and cooling? Why? They could design projects that address both technical efficiency and equitable access. In year three, we could look at systems design, so requiring cross-sector collaboration, so partnering with social work, public policy, and community organizing students, and create prototypes that are evaluated by community review panels and technical review panels. And then in year four, with our capstone projects, it could become more like a community impact portfolio, where technical documentation plus evidence of community engagement go along with success metrics that include community partner testimonials and not just working prototypes. I think the outcome from this will be engineers who understand that technical decisions that every technical decision is a value statement, and that excellence includes ethical reasoning, and not just mathematical precision, and that leadership means serving communities, not just optimizing systems. I don't think this is about making engineering softer. It's about making it better. The complex challenge that we face, climate change, public health, economic inequality, they require engineers who can navigate technical and social complexity. And the question isn't whether we can afford to transform engineering education. The question is really, can we afford not to? All right. So I want to talk about breaking the monopoly in engineering education. I think the uncomfortable truth is that we claim to prepare global engineers while only sending students to things like conferences in North America and Europe, only citing Western research or research from quote unquote elite institutions in our syllabi, or only partnering with institutions that model ours, right? R1 status to R1 status. My challenge is that engineering innovations to solve the world's problems are happening everywhere, and often the most elegant solutions come from contexts of constraint. If we think about this in terms of, say, some of the conferences that happen here in North America, ASEE, IEEE, I'm not saying that those aren't important, but I do think that they're insufficient. Because in order for us to understand mainstream engineering education discourse, we need to understand how we have to sometimes decenter the assumptions that Western approaches are universal. Conferences like the Latin American and Caribbean Consortium on Engineering Institutions, or LACSE, are using education models designed for resource constraints. As a student opportunity, these students would be able to present research to international peers and understand Latin American infrastructure approaches. Innovations they could learn from is things like Cuba and their low-cost ventilators, Brazil's biofuel innovations, Colombia's cable car public transport system, and so much more. We could look at other strategic conference engagement places that are in Europe or across the other global perspectives. So the Engineering Society for Engineering Education, or sorry, European Society for Engineering Education, or CEFI, has European approaches to engineering ethics and sustainability, which are very big there. So if we do as a comparative analysis, how do European programs integrate social responsibility? As an example, we could look at the Netherlands water management through community co-governance. And of course, we've got Hans and others here. It was from the World Engineering Education Forum, or WEEF, that have truly global conversations, including Asia-Pacific perspectives. And if we think about this opportunity, you get an opportunity to network with future leaders from over 50 countries. More strategic conference engagement would be in Africa. African engineering is where social impact isn't optional. So at the African Engineering Education Association, or AEEA, that matters more than we probably like to admit, and that African engineers must consider social impacts more because infrastructure directly determines survival. There's not a luxury of adding ethics later. For students, those learning opportunities include designing for intermittent power, engineering for limited water access, building for diverse linguistic communities, and creating things with maintenance constraints in mind. Some examples are Kenya's M-Pesa, which is a mobile banking solution that revolutionized financial access because it was engineered as a response to the banking infrastructure gap. Rwanda's Zipline, which has a drone delivery for medical supplies that help solve rural healthcare access. South Africa's biogas digesters, which is a community level waste to energy system. The lesson here is that constraints don't limit innovation. It focuses it on what really matters. Other examples from the global South include in India, the Western approach really kind of thinks about add a feature until you hit a price point, whereas the Indian approach is to start with affordability constraints and then engineer backwards. The student takeaway for this is that constraints drive creativity. A good enough solution may serve more people than a perfect solution. I use this example, the Jaipur foot prosthetic, which was created, and it's $45 versus a Western prosthetic, which is over $8,000. Other examples include community-centered design that has happened in sub-Saharan Africa. We can look at the Western approach in that is that experts design solutions and then communities adopt it. But the African approach is that communities should co-design from the beginning because maintenance requires local knowledge. A student takeaway from this is that sustainability requires community ownership, not just technical functionality. And the example I use here is these play pumps versus something like a community managed hand pump. So why did these play pumps fail so catastrophically? Well, first is that it required children to play for 27 hours or more a day to meet the community water needs for a single borehole in the groundwater. When the children weren't playing, the women had to manually spin the heavy merry-go-round, which was far more physically taxing than the traditional hand pumps were. In terms of a maintenance failure, it required specialized parts that were not locally available, meaning that the communities could not repair them when they broke down. These play pumps cost $14,000 a piece versus $1,400 for a traditional hand pump. They were designed by a joint coalition between the US and South Africa without meaningful input from the rural African communities who would end up using them. This is based on an assumption that these communities need fun Western innovations rather than boring but functional existing solutions. I think the community hand pumps were the success because traditional hand pumps had been successful all along because the parts were available in regional markets, village members were trained in the maintenance, they were designed for the actual physical capabilities and daily routines of the users. The villages were able to manage and maintain, which created a local accountability system. They were cheaper to install and maintain, and they were dignified because they didn't require you to do play when you were really performing labor. I think this is textbook community-centered design versus expert-imposed solutions because African engineers and community members already knew what worked. But Western funders were seduced by the novelty and the narratives of these innovative solutions for Africa. And rather than listening to the people who actually lived there, they created something that was ultimately unsustainable and insufficient. Let's look at Bangkok, Thailand. It was like in how we can think of adaptive infrastructure is like lessons in Southeast Asia. So the Western perspective, I think, is that we build permanent structures that are designed to last, say, 50 plus years. But the Southeast Asian approach is that you should design for modification because needs change rapidly. I think the student takeaway from this is that flexibility can be more valuable than permanence. And the example here is the Bangkok's floating markets because they've been able to evolve into flood adaptive architecture. Let's go to Cuba. Cuba has created these low-cost ventilators, and a large part of it is because since the 1860s, Cuba has been forced to develop indigenous medical equipment without Western components due to the U.S. embargo. So what they were able to do was they built their feature with affordability and local repairability constraints in mind. Those constraints drove their creativity and were able to create a ventilator that costs anywhere from $1,500 to $3,000 versus a Western ventilator that cost anywhere from $25,000 to $50,000. They had as their design priority that it had to have locally available components, repairable by Cuban technicians, and that there were no proprietary parts. This focus was on essential functionality, pressure, volume control, oxygen delivery over, say, advanced features. This design included comprehensive healthcare worker education as well. So why is this different? Well, the Western approach focuses on maximum features and cutting-edge technology, whereas the Cuban focused on the lives saved per dollar and the equipment upkeep time in real conditions and local repairability. So Latin American engineers aren't just catching up. They're solving different problems with different constraints, often producing solutions that are more appropriate for global health needs. So why do U.S. students learn about how to design for Mass General Hospital, but not rural clinics in Mississippi, Bolivia, or Kenya? Cuban engineers had no choice but to design for resource-constrained contexts, and global health benefits from that approach. Now, I do want to note that Cuban ventilators did lack some Western features, and this was an adaptation imposed by the constraints, not pure choice. All right, so this is Maharoni Owen. He's a biomedical engineer at the University of Waikato in New Zealand who's integrating Maori perspectives into the development of neuroprosthetics to address the physical, mental, spiritual, and social impacts for amputees. I got a chance to meet with him when I was traveling to New Zealand doing research on counter-narratives in engineering education. Why does this matter? Well, because Dr. Owen is looking how to integrate high-tech design into and indigenous knowledge. Neuroprosthetics are a cutting-edge technology, and it's not simple or appropriate. But his Maori-centered approach isn't happening because New Zealand lacks Western resources or expertise. It's happening because this engineer recognized that Western prosthetic designs were failing by ignoring the spiritual and social dimensions that are the embodiment of Maori worldviews, and that's something that they've always understood. This was a holistic design versus technical innovation. Te ao Maori is the concept doesn't add cultural considerations to existing prosthetic design. It fundamentally reframes what a prosthetic needs to do. Western prosthetics optimize biomedical function. Maori-informed design asks, how does this technology affect Wahakapapa, or genealogy and connection, or Wairua, spirituality, or Wanawa, family and community? These aren't soft additions. They determine whether the technology gets used or abandoned. It also addressed systemic inequity issues through design. Maori and Pacific Islanders populations have disproportionately higher amputation rates due to diabetes and vascular disease, which is itself a product of colonialism and health inequities. But as a Maori engineer, he wasn't just making prosthetics more culturally appropriate. It was like he was addressing why Western medical technologies systemically fail indigenous populations. And then if you think about this from indigenous engineering epistemology, it's like this demonstrates that indigenous knowledge systems aren't just perspectives to consider, but that they're sophisticated engineering frameworks. Te ao Maori includes concepts about the relationship between body, land, and community, and that Western biomedical engineers typically were ignored to their detriment. This engineer isn't just adding culture to science. He's using Maori language and knowledge as foundational engineering methodology. So, in terms of the narratives that we've been taught, Western engineering education is portrayed as being rigorous, innovative, cutting edge, the gold standard. Whereas things like in the global South, that education is talked about as needing capacity building. It's catching up, developing. They're looking to build towards the Western model. But the reality is that Western engineering education is well resourced, but often disconnected from urgent human needs. It can afford to separate technical from social from day one. It's optimization focused and it's solving problems of convenience. Whereas in the global South, they're resource constrained but deeply integrated into community. They must often integrate technical with the social from day one. They're impact focused, and they're often solving problems of existence. We don't send students to we shouldn't send students to the global South and into conferences for them to help or give back. Instead, we should send them to learn from engineering contexts that have balanced the technical excellence along with the social impacts, economic constraints, and environmental realities. Okay. So what am I encouraging here is like I think that is like I'm issuing some challenges, right? And so for students is that I'm encouraging them to reach out and try to seek funding for an international conference outside of North America or Europe. I'm telling them to work on capstone projects and cite research from Global South institutions. I'm encouraging them to participate in exchange programs in Latin America, Africa, and the Asia Pacific, and that they look and ask to collaborate in virtual projects, with international student teams. An example is what we're doing right now. Different time zones equate to real practice in the global work. For faculty is like you can expand your sabbaticals to go to the Global South institutions, not just research or European institutions. You can develop research collaborations with Africa, Latin America, and the Asia Pacific as equal intellectual partners and not as quote unquote field sites. You can invite guest lectures from international faculty via video conference if there are research constraints there or resource constraints there. And at minimum, you can diversify your syllabi to include non-Western engineering research case studies. As an assessment criteria, I think students would be able to identify engineering innovations from at least 3 different continents. You could ask whether they understand how context produces different definitions of what good engineering is. And ultimately, students will be able to articulate that what Western engineering education, they will be able to articulate what Western engineering education can learn from places in the global South. So I love this slide because these are my students. We were down in Mexico City for the LACSE conference in July. And is a big part of this is that I'm encouraging students, don't wait for permission. Apply to present your research at these conferences like LACSE and AEEA and the World Engineering Education Forum. Join international student chapters of the engineering societies. Seek out research opportunities in the global South. Take on projects through the Fulbright or Engineering Without Borders. I mean, try to avoid some of their saviorism challenges. It's like look to your university and ask them to help develop more partnerships. I want students to challenge their professors. It was like when they have syllabi that only include Western perspectives. Why are all our case studies from the US or Europe? Can we examine the global South context? Who are the leading researchers on topics in Africa, Latin America, Asia, etc.? I think the question we should be asking is if I can't name innovations from Africa, Latin America, or the Asia Pacific, do I actually know engineering or do I only know Western engineering? So as my call to action, I think that there are budget reality checks, right? It's like, I know that. But as a faculty, as they are putting together their research portfolios and their research proposals, if you're only putting into your budget funding for you to attend international conferences, but not students, then I think that your commitment to global competence is performative. I think if study abroad programs are only going to Western Europe, then you're teaching tourism, not global engineering. So I think that we should add into our budgets more intentionally funding for international conference travel for students, not just for faculty. I think that we need to develop institutional partnerships across the global South. And I think that we need to focus on them as institutional and equal intellectual partners, not just as service sites. And in order for us to really require a global perspective, we're going to have to think about how accreditation ties into this. And so for ABET, it was like at one point ABET was looking at as like diversity as a potential criteria. We could maybe reframe that as like into student engagement with non-Western engineering paradigms. If we stop treating international experience as an optional enrichment and make it core curriculum, I think all along we'll be better off. Okay, so here's where I think we learn humility. I think if we truly believe that engineers are here to serve humanity, then we must learn that engineers have to serve the most marginalized humans. And we must learn from the people who are serving the most marginalized humans. The Global South isn't where we practice charity. It's where we learn. It's like humility is noting that our way isn't the only way, and that creativity is a often innovation that's driven by constraints, and that purpose is understanding that what engineering must look like when it centers community needs, and justice is recognizing who gets served when resources are limited because that reveals our values. Global competence isn't about adding international experience to your resume or checking diversity boxes or feeling good about helping the less fortunate communities. Global competence is about recognizing that the best engineering education is happening in places we've been trained not to look, and that understanding that global leaders means learning from the world, not just working in it, and that admitting that Western engineering has as much to learn as it has to teach. So my question is, how can we help the global, my question isn't, how can we help the global South catch up to us? But rather, what can we learn from contexts that never had the luxury of separating technical excellence from social responsibility? So my final call to action is to join the movement. Join international organizations like IFEES, the Global Engineering Deans Council, It was like, look at places that are doing this work. Engineering for Social Justice Network, the HBCU Engineering Deans Coalition, Minds Action Network, the National Society for Black Engineers has an academic excellence program focused on international education. Go to international conferences, LACSE, CEFI, WEEF, the African Engineering Education Association Conference. Pick up books by scholars that are talking about this. Donna Riley's Engineering and Social Justice, Ketch's Trouble with Passion, Downey and Lucina's Globally Competent Engineer. Start interesting conversations on your campus. It was like, form a student working group on internationalizing engineering curriculum, or organize a virtual symposium with international student presenters. Audit your curriculum. It was like, where are justice perspectives integrated versus where are they absent? Advocate for accreditation reform. Is it my thing that I often do is when anytime I'm planning something, I always try to say, who's left out? Who haven't I included? So the next time you plan a conference trip or is like a research collaboration, or you're putting together a guest speaker list, ask yourself, am I only looking west? With that, I'll stop and I'll take any questions, comments, or concerns.
Outstanding presentation, Christopher. Thoroughly enjoyed it and thoroughly inspired by what you have to say. Wow. Look for you. So let's take a few minutes for questions and answer any questions from the audience. I think they're all, wow. Okay, so let's have some discussion, comments. I think you can just see all people applauding, but I think let's have a little conversation here, okay? Yeah, Bindu, come in. Unmute yourself, Bindu. You have raised your hand. Yeah.
Good evening, sir. Good evening. Greetings for the day, sir. Sir, you talked about the basic of engineering society. How different is it from critical thinking or design thinking?
I don't think it's different. I think that we have the opportunity to be more intentional about how we do that. I think that the critical thinking skills is oftentimes we're adding in, we'll say, okay, we're going to put the technical, and then we say, okay, now how do I add an ethical component to it? Right? How do I add a culturally competent component to it? As opposed to saying, when you put this design together, have you even thought about how these integrate with one another? So it's not that I'm saying that design thinking or critical thinking are exclusive of these. I think that they just put them on the lower priority list. And what I'm encouraging is for us to integrate them more intentionally into our conversations.
Right, thanks. Let's have Uzor Oniya. Unmute yourself, please.
Thank you.
Uzor Oniya, go ahead.
Okay, thank you, Doc. Thank you very much for a wonderful presentation and for the insights that you've given us. I'm very excited about this presentation because when I think about this, my name is Uzonya, by the way. I'm from the University of Nigeria, Nsukka. So, a civil engineering department, I'm a lecturer there. When I think about these concepts that you've been talking about, like, it blows my mind. I worry, I wonder. I always think, like, what is wrong with us in Africa? Because every time, every syllabus, every presentation, every research, every content we create, we struggle so much to copy from the West. And when you come in with a change, you face a serious resistance and opposition. It looks at everybody's like, what are you doing? Where are you from? Look at the model here. So nobody wants to apply any local ingenuity or indigenous engineering. Our people have been doing engineering. I mean, we've been building wooden bridges before the modern engineering that we copy from the West. Now, with your contribution, it has given me the privilege or the liberty to feel that someone or some other people are thinking about the same thing that I'm worried about. So my question to you now, Doc, is that can you help us maybe from your research and your work so far to share with us maybe some of the insights on how to put in some process to start unlearning some of the things that our colleagues, especially our colleagues in Africa, our colleague educators in the African engineering faculties, the fixation on Western model. How do we start unlearning or convince them that, like, some of the things that are locally construed can work or can be applied in the education system?
Right.
Yeah.
Right.
Great question. So is it, I first want to note that is it, I hesitate to use the word unlearning, right? And the reason why is because I actually think that is like, if we try to unlearn something, we try to say that it didn't happen. And I think that it's actually important for us to note that it was like, we have centered Western thought. And that doesn't mean that we stop, is like, including Western thought, but we need to elevate other thought is like to be an equal player alongside of it. And is like, I've seen this in examples where there was a library, and I'm forgetting exactly what community this was in what country, but it was in Africa. They were building a library, and they wanted to design the library on this campus building is like with thoughtfulness about the context of the community that they were coming into, and so it was actually a Western company that was really thoughtful about this and like looked at local home design and things like that. And when they built this building, they built this beautiful structure that really represented African architecture, and or brought these plans forward that really represented our African architecture. And the people at the university looked at it and were appalled. And they said, no, 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 no. You have to build it tall, and you have to build it with all the metal, and you have to build it with all the glass, because that's how the institutions in the West look. And we want to be considered as one of the premier research destinations. You can't use, as like the mud and the clay and the colors is like representative of our culture. You have to use these others. So in our decentering of this, I think that we have to recognize what is the value of this, because in building that glass metal building, particularly in a place that was on the equator, right? It was like you were going to have higher expenses, higher energy costs, the challenges and the maintenance and the repair would be way out of loop with it. But you also have to change the framework that what we have is not lesser than, but equal to what others have. And this concept really comes from working on what we call internalized oppression, and some of the cultural competency work that I do, in which we've used some of these narratives that have come from Western context to kind of gaslight ourselves into believing that we're less than. So I do have some research on this work. It's very much a part of my work in the counter narratives on engineering education. I'd be happy to kind of connect and talk more about opportunities. So please let me know if there's more I can do to support you all in these efforts.
Thanks for your response. Let's go to Manasa and Bill after that, okay? Manasa, come in.
First of all, I like to thank Krishna sir for the opportunity, and the presentation was very nice. So the QR code which is displaying, it is showing deactivated for some reasons. So
okay, I'll drop my LinkedIn in the chat.
Yeah. Okay. Sure. Thank you.
Okay. Let's go to Bill. Bill Williams from Portugal.
Thank you, Chris. Yeah, I'm based in Portugal, but I have also worked in Africa in the past. And just wanted to mention two things. I've just finished a review of publications by African affiliated authors in the main engineering education journals over the last few years. Over the last 10 years, we're going to present it at the conference in Pretoria in November. But one of the things that I noticed is there has been a significant increase in studies from African authors published in the journals over the last 10 years or so. And I know, especially in South Africa, there seems to be a growing awareness. I haven't read that many studies from Nigeria, but certainly in South Africa, I get the impression there's a growing awareness of the differences and the importance of considering the African context as distinct from what perhaps international accreditation pressures can kind of orient people. The second point, Chris, you mentioned some books, and you were also mentioning Don O'Reilly. And I remember that the International Handbook of Engineering Ethics came out, I think, last year, and it had a chapter by Don O'Reilly and various other important people in the field. And now the book itself costs well over €100. It's really expensive, but it's actually free online because they have it, it's free to everybody. You can just download it as a PDF. So that's maybe worth reminding people of that resource.
Thank you. Thank you, Bill. Comment from you, Chris, and then we'll wind up with Hans. Any additional comments from you, Chris, on what Bill
No,
said?
it was I agree with you. I agree with you, Bill. Yeah, it was I think that we're starting to see a movement where we're recognizing particularly in the global South there's an evaluation, a higher valuation of their contributions to the conversations, and I really enjoy that. And also agree much love to you in Portugal. That's where I went to write my dissertation, and so I have a very special place in my heart for Portugal. I spent quite a bit of time editing in coffee shops in Lisbon. So thank you so much for your comment.
All right, over to you, Hans, to closing comments.
I'm genuinely inspired by you, Christopher. And it's fascinating that you and I are neighbors about 2 meters apart of our offices. And you travel all the time globally, and so do I, and the global communities that we are part of. And many of the things that you have indicated, there are some very close friends of mine from different parts of the world. I just saw here Mario Chauca from Peru, a close brother, a brilliant leader who's done, I could go on and on and on and on about lots of, just a couple of comments here. This, Krishna, let's explore with Chris to continue this dialogue, and
absolutely.
It's recorded. We will share it with our teams per se, and plant something. The other thing, again, there's so many things that come to mind in terms of I'm looking right here, a brilliant book by 2 very close friends and colleagues, partners in India, Rohit and Sushma, who are leaders in our global community, Academic Leadership and Engineering Education. They are articulating, my dear friends and brothers and sisters in Nigeria and Africa are just coming out with a book that they've been working on in terms of their perspectives, following exactly, Christopher, that you're saying, per se. Again, I can go on and on. One other thing, the last 5 years, we've been publishing 5 books, and they're free now online, Rising to the Top, written by women engineering leaders of the world. There's a whole book on African women, a whole book by Indian women. We just published one coming from the Arab world in Southeast Asia, and so forth and so forth. And I'm in discussions right now with Chinese women, for example, for us to learn from them, per se. So I'm just amazed. We're neighbors. We know each other, and we share. So a couple of other comments. The engagement of students. There's a real issue, as you were saying. I mean, I just came back from South Korea. We had about 60 students, per se, and they had sessions and all that. But it's bloody expensive for a student from George Mason University, your and my university that you and I share, to come, per se. And so most of them were from that part of the world of South Korea, which was fabulous, per se. But what you're saying is a fundamental value that Krishna and I have been, and many others that I hear, been working on. So I just want to know, I just want to let you know, your presentation was genuinely inspiring. I'm very, very proud of you, Chris. Keep up this brilliant work that you're saying, and we'll continue the dialogue. Next year, we'll be in Colombia, our WEEF in Colombia, Cartagena, per se. So all of you, Chris and Krishna, this was a very, very special experience. Thank you.
Thank you so much. Thank you so much, Chris, and all the audience that has been very closely following this inspirational presentation. Good night, good morning, good day, whatever time of the zone you're in. Good health and peace to all of you. Take care, everybody.
Bye-bye.
Thank you all.
Bye-bye. Peace be
Bye-bye.
with you. Bye-bye.
Bye.